两个在竞争的一个盖出来 I just
And we're also building, so not just Australia, but around the world, we are building 2 very big optical telescopes. These are 20 to 30 meters in diameter, which is a very, very big step from our current telescopes. And these telescopes will be available in the next 5 to 10 years. And these telescopes will be so powerful because their mirrors are so big that we will be able to see some of the first galaxies. And with their spectrographs, we're designing very, very clever spectrographs which use lasers. They shoot lasers up into the atmosphere and use those lasers to correct for the motion of the atmosphere so we can get very good images of the first galaxies in the universe.
我自己也刚从日本回来，就是开一个会，下一代的望远镜是20、30、40公尺的口径的望远镜，较四个大啊，这样子的望远镜，所以它的激光能力就会很强，就可以看很远的东西，对吧？就有机会看，尤其是光是影像不好，要光谱，你才能够研究元素，研究它们的运动。刚才 Professor Kewley 讲了一些新的观测技术，你要让你东西看得清楚，让你的光线集中。光线本来就已经很远很暗了，你要让它散开来。光线为什么会散开？因为光经过大气的时候，大气扰动，对吧？星光就是跑来跑去，跑来跑去。我们要打一个雷射光上去，制造一个假的点光源，然后我们明明知道那应该是点，我们成像的时候发现它不是点。我们的电脑可以及时算出来，把我很贵做出来的望远镜变形，使得它反变形。它变形了以后，让这个原来该是点，现在因为大气扰动不是点，我要让它变回成点。变回成点以后，把上去还有我真正要看的东西，我就可以得到很清晰、光线很集中的影像。利用这种人工雷射星球的这种技术。下一代大型望远镜。
These laser instruments are integral field spectrographs, which will give us 3D data, so we can see where the oxygen is in the very first galaxies in the universe.
有了像这样子的叫自适应光学，就有了这样子的取得影像很集中的这个技术以后，我们就可以把这个光线集中来拍光。像刚刚讲的这个 IFS， 就是那种3度空间的那种光谱仪的话，我们就有希望借由刚刚讲的这些东西来研究最远的宇宙的气体。
And the other very exciting telescope is a new Hubble Space Telescope. So the Hubble Space Telescope is slowly dying. It has gyroscopes which spin to help it point in different directions. They're stopping working. It's just normal end of life of the Hubble. And also some of the instruments on the Hubble need to be kept cool, and we use a special gas to keep it cool. That gas is running out. So the Hubble Space Telescope is reaching the end of its life, and NASA has been building a new one.
哈勃太空望远镜老了啊，20几年了，还有很多问题。它的惯性导航仪开始失效，没办法好好指到一个地方。它仪器需要冷却的一些液态的冷媒，就开始漏光没有了。现在没有太空船，没有太空梭去修了，没有了，太空梭已经没有了嘛啊，所以哈勃就开始要退休了。现在 NASA 呢正在做下一代的。接续哈勃的太空望远镜。
The new Hubble Space Telescope is called the James Webb Space Telescope, and NASA has been building it for about 10 years. And last week, they just put it together at the NASA Goddard Space Flight Center. They put it together, and it's due for launch in 2018, very soon.
Yeah, 做了10年，上个礼拜终于把这个镜子拼起来了。然后，在美国的马里兰的一个 NASA 的一个基地 预计是2018年就要放到太空里面去。
Okay, and this is a movie of the launch, the future launch of the James Webb Space Telescope. The James Webb Space Telescope is very, very clever, but it requires lots of parts to open out once it's launched from the rocket. And these many different parts have been developed, and the electronics and machinery being developed very carefully to hopefully not break while it's opening.
那个东西不能太重，不能太大，所以要放上去一定是先折起来啊，去了太空以后要把太阳能板啊、仪器啊慢慢展开啊，大家希望不会发生错误。那个望远镜是用人的名字，一般望远镜呢都是先用一个代号，成功了以后我们再换一个名字。这个望远镜很特殊啊，它实际上不是科学家，是比较像工程师的。James Webb Space Telescope， 所以简称叫 JWST。JWST 呢，它是说希望在放上去打开的过程呢没有发生问题。等一下要放一段影片。
Okay, so this is a movie of the James Webb Space Telescope after it's launched.
假想的啊。
So here comes solar panels. This is a communications satellite.
太阳能板，还有那个天线，通讯的天线。
These are solar shields. They stop the special equipment being affected by the sun, the bright rays from the sun opening.
遮阳板把阳光挡住。
Some more solar shields opening up. Up. To keep it cool. Here comes the mirror. The mirror comes out. It's made of many segments.
记不记得刚刚讲要比头发还细的精确度，要靠这样子折开来。
When astronomers watch this movie, they get very scared of all the things that might go wrong. So the James Webb Space Telescope is an infrared telescope, and we can't see infrared light very well from the Earth because everything that's warm emits infrared light. Your bodies emit infrared light. All electronics, computers, TVs, lights emit infrared light. So it's very hard, and our atmosphere also emits infrared light. So it's very hard for us to see distant galaxies in the infrared. And the Hubble Space Telescope goes way outside the Earth's atmosphere to be able to see in the infrared.
JWST 啊 ，James Webb 太空望远镜主要是一个红外线的望远镜，它侦测红外线。红外线是长波啊，所以你我的身体都会发红外线，所以这整个地球整个环境都是红外线。而在这个大海中间啊，要去探测一个很微弱的太空的讯号，当然是非常非常困难，不能离地球很近，所以它放在离地球很远，它还是绕着太阳这样移得很远。
The James Webb Space Telescope has one instrument on it that's very clever for looking at very distant galaxies called NIRSpec. And this has lots of tiny little shutters which open and close, hundreds and hundreds of them. So you can look at very distant galaxies like the first galaxies in the universe and open the shutters and you can get a spectrum. And with that spectrum, you get one spectrum for every galaxy that you look at, hundreds at the same time. And that means that you can look at the the chemical elements, the oxygen, the carbon, nitrogen of galaxies at different distances, including the first galaxies in the universe.
对 ，JWST 有很多特殊的仪器啦。那当然，它作为一个太空望远镜，一代一代还会再开发。等到我们有下面的载具的时候，都会再去更新它的，就跟哈勃一样，更新它的仪器。其中有一个设备，它就讲它这个仪器，它有很多不同的快门，所以你要看远方的星系的时候，你可以看这一个，看这一个，同时就可以看很多的天体。 同时取得它们的光，很有效率。
So in the next few years, we'll be learning much more about the very early universe than we know now, and you should have a look in the newspaper, on the internet, for new articles from the James Webb Space Telescope, the new 20 to 30 meter telescopes, and the Square Kilometre Array as they detect the very, very early universe.
刚才讲的像 SKA 平方公里阵列，詹姆斯韦伯的太空望远镜，在未来的几年上线了以后，都会对我们对早年的宇宙有很大的帮助。宇宙在膨胀很远的东西不但暗，因为它膨胀远离的速度很快，所以东西都会红移，它都会移到长波长去。我们现在看起来蓝蓝的星球。 到很远的地方跑很快去的时候，全部移到红外线去。所以为什么这个詹姆斯韦伯要看红外线？不只是要看白长在云里面，还可以看很远。未来各位在未来的5年，一定会听到很多消息，发射出去10年、20年。各位长大的这几年当中，哈勃对你的震撼，就是未来20年这些新的仪器。
Okay, and I'm seeing a lot of yawning in the audience, so I might finish here. I'd like to thank the Delta Electronics Foundation as well as the National Central University for sponsoring this award and this lecture series. It's my first time in Taiwan. It's a very beautiful place. I lived in Hawaii for 10 years and I've been to China a few times. It really reminds me of Hawaii a lot. And you're lucky to live here.
谢谢你。最后这个不需要翻译了。好 ，All right. Any more question? General question?
如果有一颗第一代恒星就在我们的附近，这是有可能啊？那我们要怎么知道
The first star may well be in our neighborhood. How can we tell?
Yes, so we are doing this. Actually, that's an excellent question. Us at the ANU have a group called Galactic Archaeology, and this Galactic Archaeology group is looking at 1 million stars in the Milky Way. And there is a new satellite called Gaia satellite, and they're taking very deep spectra of the stars that have been found with the Gaia satellite to find the most chemically pristine stars, so the stars with the least amount of elements known. And so far we've found stars that look like they've just had one generation of elements produced. We recently, about 1.5 years ago, discovered that star. We think that over the next 2 years or 3 years, as we look at the 1 million stars, then we will find the first stars that were in the Milky Way at the time before the Milky Way formed.
很好的问题。第一代恒星除了如果看得远，就看得多嘛，机会比较大。可是它因为刚刚讲宇宙没有中心啊，这样看来以后，在我们周围也有可能第一代恒星，数量少，因为我们是在宇宙很小的一部分啊。他刚刚问说怎么可以看得到？那个Kewley教授回答说，譬如说有一个计划叫Galactic Archaeology 宇宙星系考古，他就要去取100万颗恒星的光， 刚才有人提到第一代恒星的特性，就是它的就是氢能氦，它的复杂元素很少，对吧？说大概一两年前找到一个，目前找到最老的了，从现在看过去最老，其实以宇宙来讲是最年轻的。从我们这边看最老的恒星，大概只经过了一代，它只富了一代，就是它才一代，从氢跟氦以后，滋润了一代的复杂元素，所以预计在未来的几年之内，等到这100万颗恒星都慢慢都研究过了以后，大家会知道更多。他提到了一个太空计划叫盖亚，盖亚是欧洲放出去的人造卫星，现在在天上，它可以很精确的量天体的位置、运动、也派光。未来我们都有很多这样的资讯。非常好的问题，谢谢。Okay. Any more questions? Or if you have answers?
If the universe doesn't have a center, will it be like the surface of the ball? If we travel far away, we'll go back to the start.
There's no edge.
There's
Not
no
like
edge.
a ball. No. No edge.
No.
So when the universe was expanding, it was the space got bigger between everything. All the space everywhere got bigger between everything. So there was no center and no edge. The way we look at it in pictures in textbooks makes it look like there's an edge. That's the only way we can draw it. But actually, there isn't an edge.
Thank you.
So if you go in one direction, in order